Hi, I'm Tina from Prep 101. In this video, we're going to talk about orthogonal and collinear vectors, and both of those are typically tested on the first exam. Okay, let's get started. So orthogonal vectors are vectors such that if you dot them, you get 0. So the dot product of u dot v, if vectors are orthogonal or perpendicular, would be 0. Technically, they talk in the textbook about acute being if u dot v is greater than 0, then the vectors are at an acute angle, and if u dot v is less than 0, the vectors are at an obtuse angle. I've never seen that come up on the exam, though. They typically focus on strictly orthogonal. So number 1, determine if u and v are orthogonal, and they give you 2 vectors. So in the context of the exam, they would give you 1 vector and then probably 5 different answers, and you'd have to dot all 5 of them and see which one gives you 0 when you dot them. So here we're going to check, is -4, 2, 0, dot, -1, -2, 5, is the dot product equal to 0? And if it is, then they are in fact orthogonal. So dot product we covered in a previous primer. So we do first times first, -4 times -1, plus second component times second component. So 2 times -2, plus the third component times the third, which would be 0 times 5. And so we get 4 minus 4 plus 0, which is 0, and therefore, yes, u and v are orthogonal. Okay, so go ahead, pause the video, and check to see if u and v are orthogonal in question 2 here. Okay, so we write down u, -3 to -1, dot v, -1, -1, 2. We do the dot, so -3 times -1, plus 2 times -1, plus -1 times 2. And we end up with 3 minus 2 minus 2. So 3 minus 2 minus 2 is 3 take away 4. So this would be -1. And so therefore, no, u and v are not orthogonal. Okay, a typical exam question that's a little bit trickier is find k so that these vectors are orthogonal. So if we know that they are orthogonal, then we know that the dot product is 0. So we can set up the dot product 4k dot 3k -7 equals 0 because we know that we're told they're orthogonal. So first times first would be 4 times 3. Second times second would be k times k. And third times third would be k times -7. And k times k is k squared. So if we multiply this out, we have a k squared here. Here we have a -7k, and here we have a plus 12. And so this involves factoring a trinomial. So when we factor a trinomial, back in high school you would have learned you need 2 numbers that add up to the middle term, which is -7. And the same 2 numbers have to multiply to the last term, which in our case here is 12. So we've got 2 numbers that add up to -7 and multiply to 12. So those numbers would be -4 and -3. Those will add up to a -7 and multiply to a positive 12. So in our brackets, we have k minus 4 and k minus 3. And keep in mind, don't circle -4 and -3 on your exam, because if k minus 4 is equal to 0, then k is 4. And if k minus 3 is equal to 0, then k is 3. So our answer would be both 4 and 3. Okay, a different style of question that people mix up with orthogonal is the word collinear. So find C so that the vectors are collinear. So collinear just means that they are multiples. Okay, so they are parallel and therefore scalar multiples. So if we look at these vectors, 3, 1, -12c, we ask ourselves, what can we multiply by to get from one component of the first vector to the same spot or the same component of the second vector? So if I look at the first component and the first, 3 times what is -12? 3 times -4. So we do the same thing in the second spot. We times by -4. So 1 times -4 takes us to c. And so c here would be -4. Now usually on the exam, they tend to use fractions just to make it trickier. So something like find k so that these two vectors are collinear is a little bit trickier. So we have 2, 12 and 5k. And we ask ourselves, what number can we multiply by to get from 2 to 5? Well, if it was a 6, that'd be easy. We'd say, oh, 2 times 3 is 6. 12 times 3 would be 36. So if this were a 6 instead of a 5, it'd be a lot easier. But when it's a fraction, we multiply by the number we want to get to on top over the number that we started with. So check, 2 times 5 is 10, divided by 2 is 5. So that works. So we do the same thing with the 12. We times by 5 over 2, which is like multiplying by 5 and dividing by 2. So we get 12 times 5 over 2 is equal to our k. And this is 12, it's 12 over 1. 12 times 5 is 60, so 60 divided by 2 is k, and therefore our k is 30. And that's our answer. Okay, and the last one here, we have 4 points, P, Q, R, and S, and we want to know whether the vectors P, Q, and RS are parallel, perpendicular, identical, or none of the above. So first of all, to calculate PQ, we do Q minus P. And so we take 2, 1, 3 minus 3, negative 2, 1. And we covered subtraction, adding and subtracting vectors in a previous video. So we subtract components that are in the same spot. So 2 minus 3 is negative 1. 1 minus negative 2 would be 1 plus 2 would be 3. And 3 minus 1 would be 2. And then if we do vector RS, we do S minus R. And so we take 2, 0, 3 minus 4, 2, 3. And we get 2 minus 4 is negative 2. 0 minus 2 is negative 2. And 3 minus 3 is 0. Now these vectors are clearly not identical. So we can cross out C. They're not identical because they're not exactly the same. Identical would mean that they're exactly the same. Now, is there a multiple we can get to? Well, if we multiply negative 1 times something to get negative 2, it'd be times 2 here. But 3 times 2 doesn't give us negative 2. So that means they're not parallel. There's no multiple that works between all the components. So we know they're not parallel. So the only question is, are they perpendicular? And if they're not perpendicular, then the answer is that they're none of the above. They're not parallel, they're not perpendicular, and they're not identical. So to check perpendicular, we're checking orthogonal. That's the same as perpendicular. So we check the dot product and we see if it's 0. So we get negative 1 times negative 2 plus 3 times negative 2 plus 2 times 0. And so this gives us an answer that is 2 minus 6, so negative 4, that's not 0. And so therefore they're not perpendicular either. So in this case, they're not parallel, they're not identical, and they're not perpendicular. So the answer would be none of the above on the exam. I hope you found this video helpful. If so, see more videos in this playlist. Don't forget to join the Facebook Study Hub. Use the link in the video description box. Also, I hope to see you at my prep sessions, where I'll show you lots of tricks on how to ace your exam. I'll go through every problem that you need to solve, and you'll solve them with confidence by the end of my prep sessions. Many of our prep sessions are free, so go to prep101.com now for more details and to sign up. I hope to see you soon. Take care. Bye.